Unit 1.2, Lesson 1, Models of the Atom. The atomic theory, the idea that all matter is made up of atoms, is a very old idea dating back to the ancient Greeks. Over time, scientists and philosophers have come up with various models for the atom based on their observations of the world around them. These atomic models help scientists picture and explain the observed behavior of matter. Scientists alter and revise these models as new scientific evidence accumulates. Scientists are now in agreement that the atom consists of a central nucleus with electrons surrounding the nucleus. As a result of this lesson, you'll be able to describe the historical development of the current atomic model, describe and draw an atomic model and explain the evidence that supports the existence of atomic structures, and describe the dynamic nature of scientific models. In the activity, you looked at how the model of the atom changed as scientists and philosophers made new observations and collected more information and deepened their understanding of matter. A model is just a simplified representation of something more complex that facilitates understanding certain aspects of a real object or process. The atoms that we are talking about, what we refer to as the smallest unit of an element that retains the chemical properties of that element. In 1803, Dalton proposed his solid sphere model, in which an atom is a solid sphere which cannot be cut into any smaller piece. In 1897, Thomson proposed his plum pudding model, in which there is a positively charged fluid with negatively charged electrons randomly dotted throughout the fluid. In 1911, Rutherford proposed a nuclear model, in which negatively charged electrons circle around a positively charged nucleus. In 1913, Bohr proposed his solar system model, in which the negatively charged electrons orbit at different distances from the positively charged nucleus. In 1918, Rutherford proposed a second model known as the proton model, in which the negatively charged electrons circle around the nucleus made up of positive protons. The most common model we will use in class is the simple atomic model. The simple atomic model takes pieces of most of the previous models presented to the scientific world. They include Rutherford's discovery of protons in the nucleus, Chadwick's discovery of neutral neutrons in the nucleus, and Bohr's discovery of electrons in orbits at specified distances from the nucleus. So this is known as the simple atomic model. Contemporary scientists are in agreement that matter is made up of tiny particles called atoms. They are also in agreement about the basic structure of an atom. There is a tiny, dense nucleus in the center of the atom. While it occupies a tiny space within the atom, the nucleus accounts for over 99% of the mass of the atom. The nucleus contains positively charged particles called protons and neutrally charged particles called neutrons. Negatively charged electrons are located around the nucleus. The mass of a proton or neutron is about 1,800 times larger than the mass of an electron. Although the electrons are very small, they move around the tiny nucleus in a relatively large space. Thus, the atom consists mainly of empty space. Now remember, a neutral atom has no net charge. This means that the number of protons in the atom is equal to the number of electrons. Scientists have created models to describe atoms. Models are usually simplified imitations of something you want to explain. For example, a model airplane is a small representation of a larger aircraft. A model can be a plan, a physical structure, a drawing, a mathematical equation, or even a mental image. Chemists create models to explain how matter is constructed and how it behaves. Different models aren't right or wrong, they simply tell you different things. Scientific evidence is a collection of observations that everyone agrees on. When a model is supported by a lot of scientific evidence, it is usually accepted by the scientific community. As new evidence is gathered, scientific models are refined and changed. This is what science is all about, a continual process of gathering new knowledge to improve our understanding of the world. The models of the atom you have studied in today's lesson are useful to our thinking about atoms and elements. Later in the unit, you will learn about additional evidence that has led to further revisions of the atomic model. Let's wrap up this lesson. How are the smallest bits of matter described? All matter is made up of extremely small particles called atoms. These particles are too small to be seen directly, even under a microscope. The atom is composed of even smaller particles called protons, neutrons, and electrons. The protons and neutrons are located in the dense nucleus of the atom. The electrons surround the nucleus. Protons are positively charged, neutrons have no charge, and electrons are negatively charged. Remember, science is theoretical and dynamic. Models and theories are continually being revised or replaced with new models and theories as new evidence is gathered.